Today we continue with what we started last time, and I have here the code from last time. I updated what we learned, and it's summarized in a little better way. I also did a few minor updates there so that the font size scales with the screen size, and the gradient works now in Firefox as well. So they are very small tweaks, and you can check them out in the source code. Today we start lecture 2, and I'm going to edit this copied file from last time, and this is going to be about drawing on the canvas. I'm going to remove this from here, and I'm going to fill this at the end of the course when we see what we managed to succeed today. So it all depends on how efficient we are at implementing the things.
Hello?
Yes.
Excuse me?
Yes.
We can't hear you. Like, the sound quality is very poor.
Okay, let me see if I can do something about that. So, the sound settings. How about now?
Now it's fine.
Okay, okay, good. Somehow the volume here in the microphone settings was bad. Thank you.
No problem.
Okay, so I removed this text from here, and I will fill it at the end of what we do today. So it will depend what we are accomplishing during today's session. Yes. Let me open also the JavaScript file from last time. And it was just this simple function here that was removing this overlay and allowing us to see the canvas with the white background. Now, if I refresh this page, it's always going to show me this, and I don't want to waste time clicking on this. So I'm going to disable this overlay somehow. And I will do that in a main function. So our main function, the first thing that it's going to do temporarily, because I'm testing now, is remove the overlay. In JavaScript, the main function like this, it doesn't really get triggered unless you specify that it is the main function. So it's a little bit different than what other programming languages have. And I'm going to say this in the body here and specify that unload, this is when the page loads in the browser, it should trigger the main function. There are multiple ways of doing this, but I do it like this because it's this main function is similar to other programming languages, and you may recognize it from there. When I now refresh the page, you can see that this overlay gets removed automatically as if I would have clicked on it because of this function call here. Okay, so now this is the canvas, and we are ready to draw something on it. I like to make modular code and many kind of functions that do different things. So let's just say that we are going to draw a scene today. What will be in this scene? I'm not entirely sure, but we will see. To draw something on the canvas, I first have to obtain the canvas somehow. In HTML, it has an ID of my canvas, and we already saw yesterday that I can get an element, for example, this overlay, using getElementById. So I'm going to say here canvas is equal to the element with my canvas ID. And now I have the canvas to work with. If I want to draw things on it, I actually need to do this thing. This ctx variable here is called the context, and it has all the methods that are used to draw things on the canvas, like lines or any kind of shapes, lines, curves, rectangles, things like that. Now this context has here a parameter, this 2D. There are some other alternatives that you can put there. For example, you can use WebGL, and that is allowing you to do things in 3D in the browser. If you're interested, you can check those out, but I'm not going to experiment with these in the course. So let's say that I want to draw a line on the canvas. I'm going to use this context. Okay, somebody was requesting permission here. Is there some problem? Can you hear me properly?
Yes.
Okay, maybe it was a mistake. Yeah. So I want to draw a line, and to draw a line you have to say that you want to begin a path, and then you want to move your, let's call it some kind of pointer, somewhere. I'm going to move it to 0, 0. So now you can imagine that you're lifting the pen and you're moving it to 0, 0 coordinate. And I'm going to draw a line to, let's say, 100, 100. And to make the line appear on the canvas, I'm going to say stroke. This should do something now. It should draw a line from 0, 0 to 100, 100, I think, if I didn't make any mistake. So let's refresh this page. Okay, there is a line, and maybe it's not what you expect, is it? I mean, this 100, 100, you would expect it to be somehow equal size, equal distance from the left, and equal distance from the top. By the way, 0, 0 coordinate is top left of the screen always. This is what happens in on your computer, and the y-axis actually grows towards the bottom. This is maybe a little bit different from what you studied in math, but this is what happens on your computer. So this coordinate is good, but this is not 100, 100. This is maybe something like, I don't know, 60, and then here maybe 120 or something like that. It's something wrong here. And the reason why it behaves like this is actually, I never said how big is the canvas. I'm going to teach you now how to debug a little bit, so I can tell the console to log the size of the canvas, like its width, and see what the default values are. If I refresh the page, I'm going to see here 300 and 150. This is a default value that the canvas has, 300 pixels vertically and 100 pixels, 300 horizontally and 150 vertically. I did say in CSS that I want this canvas to be a square, but that basically compressed it horizontally. That's the effect that happens here. It squished it horizontally, and that's why this line doesn't look like a 45-degree angle between it and the horizontal vertical axis there. So if I want this to look properly, I could say here like that. And now you actually see this line starting properly in the top left corner, and I said that the bottom right corner is going to be 100 pixels. Now, you remember that I did this thing yesterday where the canvas is stretching so that it fills whatever screen we have. And this is something quite important to talk about, because I'm basically making a canvas of 100 by 100 pixels, which is very small. And here, this is definitely more than 100 by 100 pixels. It's getting stretched very much. It's something like 500, maybe, around 500 pixels. So that's why you see, yeah.
Isn't that a raster image?
Yes, this is a raster image. Okay, we will talk a little bit about that. But everything that you stroke on the canvas becomes a raster image. It is somehow, you can think about it that if you're a painter and you want to make a drawing, in your imagination you can think that, okay, I'm gonna make a line and it's gonna look like that. That is equivalent to vector, because you can make a line on any canvas. It can be 1 meter by 1 meter. It can be the size of a building. If in your mind you can scale it indefinitely. But once you draw it on the canvas, it is going to become a raster. This is the effect of using this canvas. So when we are seeing here coordinates like 0, 0, 100, 100, this is still in the vector space. They are still mathematical coordinates, but once we stroke it, it becomes a raster, and you can see this side effect here because I'm essentially zooming here on a 100 by 100 pixel canvas, and that's why I'm getting these weird artifacts. If, for example, I put here 1000 by 1000 size canvas, and now I'm going all the way to the 1000 corner, then my line becomes very thin, becomes actually it should be less than 1 pixel, but there are some tricks here to compensate, and there is no more this artifact. So now what happens is that my canvas is actually bigger than what I have defined in CSS and I'm displaying on the screen, but it gets squished to fit there. Okay, I'm playing around here so that you understand these things, but let's see. So I could also set width for this line that I'm doing here to make it maybe a little bit thicker and easier to see. Let's set it to 10. So now it's a bit better, it's more visible here. One thing that you can actually do on this canvas is save this image. So I can save this image by right-clicking on it, and it's gonna download an image file. If I want to display this image file, I'm gonna try to open it now in the browser that we have here. Okay. You may see that there is a line here, a little bit dark line on a very dark background. This is again because because our canvas is not actually white. Our canvas here has a white background because of what we did in CSS. I remind you that our canvas is actually transparent, but we added a CSS background to this DOM element of white so that I see something there. And that's why now when I saved this image right here, I'm not visualizing it properly. So let's add the background to this as well so that I can see something there. This is me playing with different things so that you understand the behavior of the canvas. I'm not yet building something real. So I'm gonna draw a background, and I think I can do a rectangle from 0, 0 to 1000, 1000. And I have to specify the command fill. This time I wanted to have a fill. And let's give it a fill color. Let's say green, since my background in the browser is blue there. So this should work, I think. No, I think it should be fill rect, maybe. No, something doesn't work. Okay, I'm beginning a path, I'm filling a rectangle, color is green. Sorry, yeah, I remember this. This is fill style. By the way, all of these things are documented. So, for example, if you're going to go to Google HTML canvas fill style, then you will, okay, you may find websites like this W3 Schools that is explaining how to use the property, but you can also find some documentation websites like this one. I think this is from Mozilla, and it explains how the syntax works and what are possible values to put in there. So documentation, do study also yourself. There are many other things that can be done than what we are teaching here in the house. Maybe I'm gonna draw a house too. Yeah, so back to this, refreshing the page. So now it has a background, and if I save this image, it actually now saves 1000 by 1000 pixel image. So this is a relatively big image. It's 25 kilobytes on my computer, and now you can see that this line is drawn over the green background. So now the background is part of the image drawn on the canvas, and the white is still there, but it's now covered by the green. So yeah, and of course, if you zoom it enough, then you will start to see the raster artifacts here. So a little bit rasterized value on the side. But you do have control over canvas size, and this 1000 by 1000 is big enough in most situations. If you really want to remove this rastering artifact, you could put a very, very big image here, like 10,000 by 10,000, but it's gonna make a huge image size. So raster images record every pixel value, and it's not really useful in practice. Okay, it actually worked, but now this 10 pixel thickness of the line is causing some strange artifact here because of this zooming to squishing too much. So this would save me an image now of okay, it even takes some time to save the image. It's loading, processor intensive already. So this new image is wow, 1.8 megabytes, so very big, and it will look the same, I guess, but it could be zoomed in much more because the canvas is huge now. So yeah, that's kind of what you expect here. Everything is a vector until you paint it on the canvas. So that's kind of way to think about it. Yeah, okay, but let's move on. I'm going to make this canvas size defaulted to be 1000 by 1000, and I will also mention one important lesson, that having these hard-coded variables is not a good idea. So when you know that you're going to have a fixed value like this, what you must do is define a constant. I'm going to use uppercases for these constant values that are global values here. It's not part of the practices in JavaScript to have this uppercase, so the naming convention is different. It should be something like this, but I feel that it emphasizes that we are dealing with this global variable here. So now I don't have to change every time if I want to, in all the places, if I want to change this size. Okay, so we have some line, but I also plan to build something more complex today. So when I saw that house, I was a bit smiling because I also have a house that I want to draw. And I'm using here some percentile values of the canvas so that it will be pretty much the size of the canvas no matter what my size here is going to be defined. So what I'm going to do now is I'm going to try to draw these different shapes and to see how it looks like. But when I do that, I want to point out that in this coordinate system, I have placed 0, 0 here in the bottom of the house. So this will be clear why I do it later. Basically, I want the bottom of middle of the house to be the coordinate of the house. And if I just draw this now, it will not look like anything because this is where the canvas starts in the top left corner. So I'm basically drawing the house away somewhere on the canvas, but not in the visible part of the canvas. And bear with me for a moment while I draw these lines, because then I want to teach you how I can translate this to any location. I basically want to make a function that allows me to draw this object maybe multiple times, maybe with different sizes, maybe rotation or things like that. And I'm teaching you different methods in the canvas using it. So here I'm gonna make a function called draw house. And let's say that I want to draw it over the canvas. So the bottom of the house is going to be at coordinate size divided by 2. So horizontally in the middle of the canvas and vertically at the size. So this is going to be the location where I draw the house, and I'm going to have to pass here the context as a parameter. And I will remove these things. These were just me playing previously. So now the function that we concentrate on is going to be this draw house with a context and a location array. So here I have an array with 2 values. First is the horizontal offset and then the vertical offset. Yeah. And I paste the previous code here because I will reuse some of the components. So how does this house look like it has one triangle starting here in the top left, this minus 50%, minus 60%. So I'm going to say, okay, let's comment these, maybe they are gonna be useful later. I'm going to say begin the path and not move to 0, 0, but move to minus 50%. So 0.5 basically, that's 50%, multiplied by the size of the canvas. So this is 50% of the canvas, and vertically I want minus 60%. So I just copy this here like that. And I do a line to in the horizontal direction to this plus 50, minus 60. So let's just do something like this. A line to the top, so to 0 and 100. Of course, I could put here just 0. Everything multiplied by this is 0, but it's easier to read in this way. I'm keeping it like this now. And 100% is 1. So this is now 2 lines, and I need another line to the beginning. So basically I can copy this from here and just change it into a line 2. And this should work, but I'm not using the location in any way. So if I run the code now, let's see. If I run the code now, it's empty because the house is going to be drawn, I think, somewhere here in the top left region, not in the visible part of the canvas. So I could, for example, add here the first component of the location and the second component of the location. Maybe I do that just to demonstrate. This is how you translate basically coordinates if you want, and I hope it works if I didn't make some mistake. Okay, so the roof is there and it works, and you can see that this is kind of becoming very long and kind of hard to manage these long lines of code. And I could do this multiple times. For example, maybe I want to draw the house not just in the middle, or okay, also in the also a little bit to the right. So now I have the function, it's a modular function, and I say draw 2 houses here. So basically at the moment I only have the roof, but I am getting one house in the middle and one house a little bit offset to the right. So this is working properly as I kind of expected. Of course I still have to draw the bottom part. But I want to teach you another method that is making this type of working here, of writing here, more easy to read and more convenient. It's actually the canvas has these methods for translating and also for scaling. So for example, if I say here translate to the location, then I don't need to specify this anymore. I can just leave it as relative to 0, because now what has happened is that the 0 offset of the canvas moved where I want the house to start, which is down and in the middle. So this translate method allows me to make the code much simpler and not worry about bugs. I have a lot of code that also has similar style, and causing those long lines I can introduce more bugs. So this type of of writing is actually quite convenient in this case. And when I refresh, I see it works for one house, but the other one disappeared. And the reason why this happens is that this translate is called once here in the first, and then called again. So what has happened is that it first moved to the bottom middle, and then moves again to the bottom middle somewhere off screen. So I need to restore this translation somehow, and this is important thing to do here. So I think it is reset to the previous saved value. So I'm storing the properties of the context with this save. I'm translating it, doing my thing, and I think this is reset or restore, I don't remember. Let's see. Yeah, it's not reset. I'm getting a warning here, an error in the console that context reset is not a function. So this is restore. And now I get the same behavior as before, but the code is cleaner. I can do the same thing here for the translation with the size. Let's say that I want the size of this house to be smaller in one function and bigger in another function. Now everything here is scaled by this canvas size, but maybe I want it just half the canvas size, or whatever the parameter I want to give it. Maybe I'm going to say the size, let's give it half here, and let's give it 1/3 here. So I will need another parameter, and I could use this here, and it's gonna work. So this is what's doing the scaling for me, I think. Okay, you see something has happened. So the houses still start in the middle here and a little bit offset to the right. So the 0.5 is the middle and 0.6 is the offset to the right. The one on the right is a little bit smaller now. The one on the top is a little bit bigger, the one in the middle here. But again, there is another method that you can make the code simpler, which is called scale. And the same thing that happened before, I can do here as well. I can basically scale the context, and then I can work here with these normalized values instead, which makes the code much more readable and again more difficult to make mistakes here. I'm getting some big unexpected results. I think it is because this line width now has been rescaled in the same way, and now it became something really big. Let's try to define this line width as a fraction, a percentile fraction of that. I think before it was 10 out of 1000, so I think something like this will look similar as, or no, well, yeah, let's work with it. Okay, so these are some methods that you will need to use. Things like lines, moving, the stroke, fill, we are commenting it here, but I will soon use it again. Let's build the second part of the house. So now I have just this roof and I don't have the body of the house. So for that, I'm going to use this rect object, I mean method, sorry. And I'm going to say,
Excuse me,
yes,
I don't understand why there is no like size anymore in the CTX line 2.
which line?
The 31 or 32.
So what happens here, this translate method of the context, the translate method of the context, if we check these documentations, now you can see. So what happens is it basically moves the canvas, and the scale method of the context actually stretches the canvas. So because the canvas itself is modified prior to my drawing here, I basically said canvas should move and resize itself where the house is going to be, and the house will just take its full normalized values in that space that I designated for it to be drawn into. So it's you don't necessarily need to use this translate or scale. You saw that you can get the same outcome as I tried previously, but in this way you are less likely to make mistakes, and the result is quite the same.
Okay.
Yeah.
Okay, thank you.
Sure. But anyway, these are things that you will need to experiment, and I am teaching you various ways of doing these things. Okay, so for the bottom part of the house, I need to start a rectangle here at minus 50, 60, minus 60. And I need to do it with a width of 100%, so 1.0, and a height of 60%, so 0.6. And I'm going to stroke it. Okay. And now the body of the house is also here. Now you can notice some weird things happening, like for example this corner here goes out, here the corner doesn't go out. It's a little bit confusing. Basically I would need to tell the canvas that okay, you need to close the path here, so there is a method for that. Now it looks a little bit more symmetric, like what you expect it to be. Let's move these houses a little bit so that it looks like something more realistic. So maybe I'm going to move this, make this one a little bit smaller, put it slightly upwards, and the other one, which is even smaller, even more up, so that it kind of looks like a perspective view, like one house is behind the other. But let's make the one in the front a little bit, move it a little bit to the left, so that I see the house behind better here. Okay, so you can see that I'm having here now the location and the scale as arguments to this function, and I could pass many things here. So the difference from drawing like this to drawing, let's say in Illustrator or Photoshop or whatever, and then importing the things, is that I have the option to resize any size I want without loss of quality. And I have option to maybe change the color immediately, or different kind of proportions. Basically, I could specify here let's call them properties, and I can specify here any properties that I want to this house. Like maybe I'm going to say, let's try to give it levels, like if you have a building with more floors. Let's say levels, and let's give it 4 levels. Let's give it a color for the walls. And let's say brown. A color for the roof. Funny color brown because it doesn't really exist in the spectrum. If you think about the rainbow, there's no brown in it. Basically what we understand is dark orange. So now I'm giving some properties, and the reason why I'm doing this is because I don't want this line to become very long with many individually specified properties there. I just group them all inside the this one object here. So this is an object in JavaScript, and it has 3 different properties. Right. So how would I go about the levels? Maybe, okay, I'm gonna try to do something here. I'm going to move the code for the body of the house, say on top, and instead of drawing it to have 0.6 height, I'm going to draw it level by level. So I'm gonna have one level be 0.1, for example, and I will duplicate this code 6 times by translating in between. So let's see what we get if I do this. I'm gonna write a simple for loop. Okay, starting from level 1 to the levels that I defined previously, which is 4. And every time I draw one level, so now I'm basically drawing the bottommost level and then the next one and the next one, but all of these coordinates are the same. So it's just gonna draw 6 times a very small, a very not tall, short rectangle. So at the moment it looks like this. I want them to, so there are 6 of these rectangles, but they are on top of each other and I don't see them any differently. So to see them differently, I will use again this translate method so that I practice it again and you understand a little bit better how it works. I'm not going to translate at all horizontally, but I am going to translate vertically by -1. Okay, then here. So the end result of doing this is going to be that. What you may notice is that okay, now I see 4 levels here, but the roof also moved because this translate moved the entire canvas, as I showed you previously, and these coordinates now don't work anymore. They should be relative to the last piece, that the last floor that was drawn. So actually, after drawing the last floor, I translated upwards by -0.1. So here I don't need this vertical component at all. The translate method moved the canvas at the proper position for me. And yeah, I also have to move the pointy tip, which is now 100% upwards, maybe to a more manageable, nicer looking value. Of course, this also can look nice, but oh, sorry, I meant to say 0.4. So I'm preserving basically more or less what was in the original design there. So now, because of writing the code like this, I could define different properties for the second house. I could say maybe I wanted to have, maybe the first one could have 6 levels. And the one in the background has just 4 levels here. So you can see how it's changed. And you can really go and do anything you want here, any kind of design choices. One thing when drawing things like this, if you want it to look realistic, is you shouldn't use so precise coordinates. It looks kind of fake, like artificial. Houses in reality, especially if you think about wooden cabins or things like that, they may have some kind of imperfections here and there. So you could play with the rotation, for example. Maybe you have one level be a little bit offset in rotation. It's not just perfect. And let's see how that would look like. So instead of just translating here to the top level, I'm going to also rotate the canvas. So this is now another method that you can use on the context. And I'm going to rotate it with, let's say, 0.1. So I'm getting this kind of weird effect. 0.1 here is in radians. So do you know what the difference between the degrees and radians is? I probably should mention this here. So So degrees and radians are the ways that you can measure angles, and there is this relationship between them that you have 360 degrees is 2 pi radians. So now here I'm specifying 0.1, which is a small fraction of pi. If I would specify here something like this, then you can see that the floors are forming this 45-degree angles, because this is what pi divided by 4 means in degrees, which are more commonly used by people. But anyway, I'm mentioning this rotation here also as a tool, because it's not easy to generate an image like this if you don't know this rotation method. You basically would need to figure out what are the coordinates of each of these points here where the levels are starting. And that's some serious trigonometry there. And because of this rotation method, translation method, and scaling methods, which are built into the Canvas API, you can kind of cheat a little bit and don't need to understand the full math. It's enough if you understand the behavior, and you can do tricks like this. Maybe more interesting, instead of using a fixed value there, would be to use a random value. Random method from this math class gives you a value between 0 and 1. So it could be maybe too high. I'm going to scale it down a little bit so it's between 0 and 0.1. And now, actually, when I refresh this page, you can see that depending on this random value, the houses look a little bit different. They don't look the same. So I'm basically generating different scenes every time I'm refreshing this canvas, which is again something you couldn't really do if you design these images as sprites and then you want to add them in some game or something. You have basically a more organic result here with objects that don't necessarily look the same every time. Now, I don't like that they are slanting to the right. It looks like a very, very windy place there and somehow affecting the things. So maybe I'm going to subtract from this random 0.5 first. If I do this, the value inside this parenthesis is going to be between minus 0.5 and plus 0.5. So now my tilting is going to happen in both directions. And again, I'm scaling it down here a little bit. So it depends very much on these random values. If I'm going to scale it a little less, so maybe I replace this with 2 or 3, I'm gonna see this effect a little bit more, but it gives kind of the impression that, okay, these are some imperfect objects there, maybe some wooden huts in the forest, and it's kind of a nice thing to be able to draw like this procedurally. Okay, but our properties. These colors here, I'm not using them in any way, so let's implement this color from here, and maybe say the fill style is going to be from the properties the wall color. So my wall color attribute from here is going to be the fill style. And then after it's drawing the walls of the house, it's good to have these kind of in sync. Like if you're talking about walls, refer to them everywhere as walls. And after you draw them, you have to draw the roof. So I'm going to take from here the roof color and basically replace the fill style, which was previously the walls. They are drawn here, and then the roof is drawn. But stroke doesn't make the fill happen. I need to specifically tell it also fill. And now I'm getting also colored things there. I'm not entirely sure if the strokes are even needed. Maybe they are, maybe they're not. The red for the roof is kind of too bright. Maybe I try some dark red. Notice that I only changed the property of the second house. I forgot that this property is distinct, but it can be anything really. You could even make your code get a random color somehow. So we talked a little bit about this yesterday. Maybe get random color. We can make a function for this and say return. You remember I had this RGB A function for red, green, blue, and alpha. It also works with RGB without the alpha, and then it has just three parameters. But let's leave it with the alpha and try to define a random color here. So the red component, green, blue, and alpha is transparency. So it means that something in the background could be visible through the pixel value of the object on the top. We need to basically specify colors here. So 0001, I think, is going to be black. So if I replace here the dark red with get random color, I expect to see a black roof for this house in the background. But this is not random. So to get random values, I need to figure out what would be here a value for red. And I'm going to use the random method again. This gives a value between 0 and 1, but my color values actually range from 0 to 255. This is how colors are defined in this RGB format. So 255 means maximum amount of red, for example. So I need to here multiply this by 255. And because I want to have integer numbers, I'm going to floor this value so that I won't get some value like 96.32. And this is my random value for red, green, blue. And I just need to concatenate these values here. In newer JavaScript syntax, it's possible to write these things also a bit nicer, but I won't bother with it, with explaining all these things. And now this other house, the house on the smaller house, has a different color roof, but this color of the roof changes every time I refresh this page. So basically, if your scene is gonna have like maybe 100 houses, you could simulate, for example, a village where everybody has different colors, different properties, and maybe you don't want to have all possible values for the colors, and then you need to learn a little bit how color works and tweak these values a little bit differently. So yeah, but now I'm doing this for one of the houses. So the small house is going to have a random color, and I see here a mistake. The small house, which I wanted to appear in the background, is drawn after the big house is drawn. So this looks kind of like a weird optical illusion thing. I'm expecting perspective to happen, the smaller house in the background, but it's floating in front of the other house. So I can draw them here in different orders, and it's gonna solve that. So the smaller house first, and then the bigger house is gonna be on top of the smaller house. I didn't see this previously because they were just the strokes and see-through in the middle, but then it became apparent. Okay. So what do you think about this? Is there any kind of questions, difficulties? Is this clear? Is this confusing? The reason we record this is that you can look anytime you want at these things. Okay, some questions in the chat. Are the coordinates in pixels? Yes, they are values in pixels here, but imagine that your canvas has its own coordinate system there. So basically, we are stretching the canvas or squishing it, and it becomes how to say, it's a squished pixel. So relative to the canvas, everything here is in pixels, and our size of the canvas is 1000 by 1000 pixels in the beginning. If I'm gonna change this to 100, then because everything that I drew here is relative, so I'm drawing everything relative to this size by scaling it properly here. You can see that it actually works. Even if my canvas is now 100 by 100 pixels, my resulting image still looks as expected. But this is a much lower quality image than what we had previously. So when the canvas is stretched to my screen size, these kind of artifacts start to appear again. I think there was also some, yeah, so I'm recording everything, and in the chat here there should be a link in the beginning to the page where the recordings are going. You can also find people recording these inside Teams, but they will be both here and on YouTube. Okay. So if this is clear, then I think that we can play a little bit more with these with this drawing and make it a little bit more realistic and practice some more methods. I'm gonna make the canvas size be 1000 by 1000 pixels again, so that this artifact from the stretched image doesn't appear anymore. Of course, maybe other properties would be nice to try, like door. This could be a Boolean value. So basically you could ask, do you want the house to have a door or not? It's kind of silly if the house doesn't have a door, but in life it could be on another wall or in the background. So this could be one of your properties. And of course, drawing this door is this can be done using the same kind of tricks for the, like maybe you draw a rectangle there and color it differently. Or I don't know. Do you have something that you would like me to update this app with, or should I just experiment with more things? Maybe I'm fine with houses in this level, but the background, I'm not happy with the background. They are just floating in this whiteness. So let's make the background a little bit nicer. Maybe it's gonna be some green grass on the bottom and some kind of blue sky in the back. So here I'm drawing the houses. Maybe I want to draw background on the context, and I don't need to specify it, probably anything else. This is going to be a new function that we are building now. Draw background on the context. And pretty similar as before, you could, for example, use the rect function. So begin path, fill style, green, and now I'm going to draw a rectangle from, let's say I want vertically to start at half the size, so, and horizontally it can start in the far left, so 0. And the width is going to be the full size of the screen, and the height is going to be just the bottom half. So I'm going to draw a green rectangle in the bottom half of the screen. I have to fill, and guess this probably works. Let's see. Nope, it doesn't work. So what is wrong with this? Oh, I made a mistake here. This is the horizontal value. So horizontally, I want it to start in the left, and vertically, I want it to be in the middle. Yeah. Okay. So this looks a bit nicer, maybe. Let's make some more houses. These small, more of these smaller houses in the background with random roof color. So the house in the front is gonna have the dark red, but these in the background, they are gonna be with 4 levels and random roof color. So I'm sending the same properties to this other house in the background, and can offset it a little bit here, and I make it a little bit smaller. Okay, it should be drawn, because it's in the back, it should be drawn previous before the one that is slightly bigger. So now I have 3 houses there, and you can see that the ones in the back are sharing the properties. They are sharing all the properties, like the number of levels and the roof color. Okay. Yeah, I think that's fine. What else? Well, similar thing you can do for the sky. So maybe light blue color, and the sky is going to be in the top part. So instead of starting here at the half of the screen and drawing the rectangle in the bottom part, I'm going to start at 0 and draw a light blue background in the top part. So, okay, it's not that visible, but it is different than previously. So one thing that you can experiment with here is curves. This is going to be part of your exercise session. So all the lines that I'm drawing here are straight lines, but the canvas also supports curves, and it will be a self-study exercise. You will need to modify this code that we have here and make some curves appear somehow. Maybe you have the roof slanted, or maybe those beams that are forming the house could have some maybe rounded corners or things like that. Maybe the background, it doesn't have this straight line here, but maybe it's like a hilly background. Yeah. Let me think, do I want to teach more properties of the canvas, or is going to be enough for the drawing? By the way, you can always say that you want something to try something, or if you are curious how you would do something, just ask. Otherwise, I will probably continue to do some things here, but repeating the same methods. So you will have some kind of self-studying to do, but it's pretty much these are the basic components. From my point of view, if you can draw a line, then you can draw anything. So it's very important to master these methods and components. Okay, so if nothing new, then I just continue random stuff. I'm gonna make a new function. Let's have some trees in the background. Or wait, in theme. No, there is no function for drawing triangles like that. But of course, even this rectangle function, you could simulate it by drawing 4 edges instead of 3. So you can draw any polygon. Actually, removing drawn object. No, this is very good question. So if you want to remove some object that has been drawn, like later in the future, you basically need to redraw the entire scene. It's a bit bummer. You have to redraw the entire scene without that one object that you are going to want to remove. Really try to think about it as the canvas that the painter is painting on, like artist guy. He draws something there, some character there. He can't remove it anymore. Or you could remove it if you try to hide it. Maybe draw a green rectangle on top of the object. If the background is green, then it starts to be, it looks like it's not there anymore. So it's pretty much the same as what the artist would do and experience there. There are techniques for layering. For example, let's say you only have one object that you want to redraw all the time, and the background is stationary. Then you could actually have two canvases on top of each other, because they have transparent background, so the canvas on top can have the moving object. And then this moving object you can remove anytime by removing the entire canvas, clearing everything from the canvas. So basically, yeah, that's something that I could teach, but maybe we leave for next time. Because if I clear the canvas now, well, I can show you that it works, but the method for clearing is clear rect and 0, 0 size. So this is gonna clear my entire canvas. But if I do this now, you don't see anything anymore because I drew all the things and then I removed it. So if you have two canvases on top of each other and then the one on top has only one object, doing this clear is going to remove that one object because everything else is on a canvas that is below. This type of layering technique has been always used in animation since the early times, and you probably remember in some, or if you watch some older cartoons, you can always see the character that is going to move looks different than the background because it is drawn on some kind of layer on top of the background. So it's kind of a different paint or different kind of layer material there. It makes the paint look different or things like that. Yeah, okay. Levels of the building. Horizontal lines instead of rectangles. Yeah, so I could use horizontal lines, but so the way I visualize this is that they are not like a conventional building like that you see on the street now, but some kind of wooden hut, a little bit deteriorating, and it's made from these beams, like wooden pieces, and that's kind of the effect that I'm going for here. That those are slanted a little bit because of the how it was built, or because the time was passed, and yeah. So of course you could draw lines with the line 2 method, and then you don't have these different blocks positioning like that. So it's kind of like an abstract effect I'm trying to get here. Okay, maybe working on the house more. So let's add a door to the front house. So yeah, I probably need to, because of my translations and rotations and all the processes, I need to draw this door after the body of the house and the roof have been done. I need to I probably need to get again these properties. I'm translating again to the middle of the screen, so basically not at the middle, at the bottom of the house, at the bottom center of the house. And yeah, I will draw this this rectangle for the door. So this rectangle is going to start, let's say 0.1 horizontally, minus 0. Let's say 4, and then it's going to have a width of, let's say 0.2 and a height of 0.4, so something like this. And the fill style, let's just make it black. idea that it's just an opening and you see the inside of the hut through this door. I don't want to add so many different colors here. Okay, there is some kind of door there, but oh yeah, because I'm translating again, I need to restore, otherwise my canvas has been shifted to that house and then it's going to shift again probably off screen for the next ones. So now I have some kind of door there. It's a little taller than the house frame here on the smaller ones with 4 levels. But it's okay. I think that door should be independent of the level size because people have similar height. It's not like more levels needs a larger door. So it's kind of, yeah, I think it's just fine. But I said that I want to draw the door only on the front house. So because that's the house that I gave the property door to be true. The other one is going to be assumed null or undefined or something like that. So if I check, for example, if properties door is equal to true, and only then do these things, it's only going to draw my door for the house that is in the front. So kinda that's how the things work. I think my houses are a bit too slanted, so this effect is going a little bit out of proportion. Maybe I make the rotation here a little bit less by reducing this value. So these values that you see here are still hard-coded values, but they are okay in a sense that they describe the blueprint of the house. So it's part of the house's way of being, kind of. This would look a little better as object-oriented programming, and we may do this next time when we animate some things. But yeah, basically they are part of this blueprint here, the house properties. So they are describing how big the roof is, how wide the levels are, and how tall they are, and this has to come from somewhere. Yeah. Okay. Did somebody have some question? I think somebody turned their microphone on for. Okay, so now only the front house has that door. Okay, so yeah, I think I can still do a small different object. So let's make a quick tree so that we don't have just houses there. And I'm gonna make the tree by modifying this house a little bit. So draw tree maybe, and it's gonna be quite similar. It's gonna have a location, a scale, and some properties. So pretty much the same parameters here. I will translate it to the bottom, scale it somehow. Instead of making the walls like this, I think I'm gonna just draw the trunk of the tree. So So the trunk is going to be a small rectangle starting from somewhere close to the center, let's say like that. And yeah, let's just leave it like this. And I'm going to comment out the rest of the code for now. just to see where the trunk is going to appear, and then I'm worrying about the leaves. And let's draw it somewhere, like maybe I'm gonna put it behind the big house somewhere on the left here. Let's see. So draw a tree on the context, and gonna copy some properties from this house that is on the front. Shifting it to the left a little bit, and yeah, let's see if this appears anywhere. Okay, something appears here, but where is my house? Most likely this restore I commented out, and it's important. So this is something you definitely need to remember. If you translate your context, restoring it is going to be important. Otherwise, the things may end up different locations. So yeah, the tree, it's there a little bit behind the house. I'm going to make it just a little bit no. Doesn't seem to work. Okay. Yeah, if you want to draw a curved road starting from the door, that's what you have to do in the exercise class. So I mentioned two functions at least that would be useful for that. It's the Bezier curve 2 and the quadratic curve 2. So instead of our move to and line 2, you will have to self-study how to do the curved paths and try to modify this code like that. Okay, now this trunk of the tree is a little bit more visible, and maybe I'm gonna put it a little bit more up. Okay, and now I'm gonna try to draw something here. Maybe I reuse the roof way of doing things. I just make it from triangles. So it's gonna be this abstract tree. If you're really interested to draw things more realistic, then you could look some of the things that I have on YouTube, because there are some different techniques. Like maybe you want to draw it using fractals, and well, that gives you a more realistic look. And I have several videos on that topic. But now it's basic drawing things on the canvas, so not so deep. You could use a fractal topic for your project though, so maybe check those out. Okay, yeah, so I'm going to draw now the leaves of the tree by making these kind of triangles similar to our code from here. And maybe I'm gonna give it some levels as well, so that the tree maybe has more triangles as we are going through the properties. So property, this level property basically. Okay, let's see what happens if we just do this. Okay. Again, I think I removed that restore. Yeah, and the roof of the house is here, but I actually want it to become something like a tree. So, okay, I don't think I will have time for levels anymore, but I will just make it look like a spruce, like a very, very very, very simple looking spruce. Okay, and it needs to be slightly up here, I think. Yeah, so that I can, okay, where is the trunk? I don't see the trunk anymore. I'm gonna hide the house in the front ground and see how the tree looks like. Okay, this tree doesn't look good, so where is my trunk here? It should be here after the rectangle, but then okay, I will clean up the code because I won't have time to do levels on the tree, but I still want to finish it so it works properly. So let's see if I remove the leafy part and I show the trunk again. Okay, is there, but for some reason these coordinates are, oh yeah, okay. Yeah, I probably should still translate these somehow. For debugging, I'm gonna make different color here, so I'm gonna give it 255 green, and I'm gonna give it also a bit of transparency so that I see what is behind the tree. So now I'm drawing the tree with the transparency, and I can see behind where this trunk is, and I can position it relative to that one. So yeah, I don't have patience, I think, anymore to do this properly. So I'm just gonna eyeball it, I think. Let's see. So I'm gonna translate it a little bit to the left, it seems. Yeah, too much to the left. You can tell that I'm getting a bit tired. Yeah, and the top is something like that. Very beautiful, very beautiful tree. And I reactivate the house now, and I think that we are done with me playing around. So there are more methods. You will need to do some self-study with those in the exercises, but that's pretty much it for today. So do you have questions about all these things that we have done, or is everything clear?